Today we are going to begin with the end in mind by thinking about what we are going to learn today. Today our learning target is I can use models to show equivalent fractions. We have discussed the word models um, several times in math, and we talked about how in math a model is something that shows how to do some kind of task. Like it may show, in this case, it's going to show us a fraction, but we've also used models to show multiplication, division, etc. Now, if you look really close at this word equivalent, if you look at the first part of this word, it sounds a lot like a word that you may know. Equivalent sounds a lot like equal. And that's exactly what it means. Equivalent fractions are fractions that are equal. And today we're not going to create equivalent fractions. We're going to use models to show equivalent fractions. But before we begin, let's think about a fraction, because we haven't talked about fractions. Now, fractions have two parts. They have a top and a bottom. But the top has an official name. Do you know what the name of the top number is? I'll give you a hint. It starts with an N. It is numerator. And the bottom number, or sometimes I like to think of it as the down number because that word begins with a D. It is the denominator. So we have the numerator and we have the denominator. So let's take a look at this problem. Joe cut a pan of brownies into third size pieces. So here's our model, and this is, just imagine this is a pan of brownies, and he cut it into third size pieces. So there's 1, 2, 3 parts. He kept 1/3 or 1 out of 3 and gave the rest away. So the very first thing that we can do is we can take 2 of these pieces and we can mark them out because Joe gave those away. He only kept 1 out of 3. He will not eat his part all at once. How can he cut his part into smaller, equal-sized pieces? Okay, he could do that in several ways, but let's look and see what the problem says. It says that show how Joe cut his part of the brownies into 2 equal pieces. Well, that's pretty easy, right? You can go horizontally. You could have also gone vertically. Either way, it would be 2 equal pieces. You can rename these 2 equal pieces as a fraction of the original pan of brownies. So suppose Joe had cut the original pan of brownies into equal sized pieces. So let's just pretend that Joe had cut the whole entire pan into equal sized pieces like this. How many pieces would there have been? Well, there would have been, if you come over here and count, there would have been 1, 2, 3, 4, 5, 6. There would have been 6 pieces. What fraction of the pan is 1 piece? So 1 piece would be 1 out of 6. What fraction of the pan would 2 pieces be? That would be 2 out of 6. So what that means is that the part that he kept for himself, which is 2 out of 6, is equal to 1/3. So 1/3 is equal to 2/6. So we just modeled how originally this was 1 out of 3, and we changed it to 2 out of 6, but it's the same size brownie. We didn't do anything except cut it in half. But let's think about what if Joe decided to cut his part of the brownie into 4 equal pieces. So now remember that we're going to pretend that he did this before he gave any brownie pieces away. But remember, he only kept the part that's not marked out. He gave all the rest away. Okay? Now, that's not 4 equal pieces, is it? Let's try that again. All right, so that would be 2 equal pieces. So what if we did this? Now it's divided into 4 equal pieces. Okay. How many pieces would there be in the whole pan? There would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There would be 12 pieces. What fraction of the pan is 1 piece? So 1 piece would be 1 out of 12, or 1/12. 4 pieces would be 4 out of 12, or 4/12. So if you look back up here at the original piece, that was 1 out of 3, and we changed it to 4 out of 12. We didn't add any brownies, we didn't take any away. All we did was divide it. So 1/3 is equivalent to, that says 4/6, but it should say 4/12. So let's take a look at another problem. So Savannah has 2/4 yard of ribbon. Okay, so here's a piece of ribbon divided into fourths, and she has 2/4. And Lynn has 3/8 yard. So we have this piece of ribbon divided into eighths. So Savannah has 2 out of 4, and Lynn has 3 out of 8. How can you determine whether Savannah and Lynn have the same length of ribbon? So we're going to take 2/4 and 3/8, and we're going to shade the model. So I'm going to use this. We'll use blue. All right, so we've got 1, 2 out of 4, and then we've got 1, 2, 3 out of 8. So when I look at these two models, the first thing I notice is that 2/4 is bigger than 3/8. So we would say that 2/4 is not equivalent to 3/8. 2/4 is actually greater than 3/8. So how could we compare these fractions without a model and still be able to tell whether they are not equivalent? We will talk about that tomorrow.